Hi guys, what's up? This is my first video on the analog communication, which, as you know, this is the fifth semester. This is for credit subject. The people who can see this video, those who are preparing for the semester exams, this video is totally based on the semester exam. And if I would recommend, if you want to get more concept on this particular topic, please refer NPTEL videos where the videos made by the renowned lecturers from the IITs and the NITs. So that videos are more good in terms of concept. This video is totally actually motive to make this video is just to get the good concept about the topic and clear the exams. And even you can use this video for the preparing any gate and PSUs. You can. So let's start the first module of the analog communication, which is in our syllabus. So let's see the module 1 syllabus of analog communication. Here you can see the red colored topics. You can emphasize on this topic more because this topic, according to me, are more important. All topics are important, but you can give more emphasis on these topics. So let's brief all these topics. What we have, a introduction to analog communication. So in this topic we have to study what is analog communication all about, how the analog communication system looks from the transmitter to receiver, and in between there is a transmission channel. Apart from this, why do we need communication? We have to see this, that the total analog communication is about modulation and demodulation, and what are the needs for modulation and what are the needs for demodulation. So actually the concept of modulation is we have to understood that why do we need the modulation. Apart from that, we have to study the continuous wave linear modulation. In this topic we have to study the first topic, which is AM amplitude modulation, which is also known as a DSBTC. The time domain representation of an AM signal, its expression, how its signal look. Then we have to understood what is modulation index, which is very important in terms of exam. We have to see the frequency domain representation of a AM modulated signal. Then we have to look the illustration of the carrier and the sideband component. We have to look as well the bandwidth of AM signal and the phasor of the AM diagram, AM signal diagram. Okay. Apart from this, the more important topic in this AM is the what is how we can calculate the transmitted power, its sideband power and its efficiency. Concept of under, over and critical modulation we have to understand. Apart from this, the other amplitude modulation technique like double sideband suppressed carrier, single sideband suppressed carrier, its bandwidth, its transmission power of all these particular double sideband, single sideband, we have to get the idea what are the transmitted power, what are the efficiency, and how much this technique is more efficient than the previous technique AM. Then we have to understand what is PSB, which is the vestigial sideband, and its importance over single sideband. So this is all about the module 1 syllabus. So let's proceed with the module 1 topics one by one. Guys, let's start with the first topic we have in our module 1, which is element of communication system, where you can see the entire communication system is being divided into the 5 major segment, which we have information source and input transducer. Then we have a transmitter, then we have a channel receiver, and at the end output transducer. Just concentrate about the three major part. We have a transmitter, then channel, and then receiver. These are, we can say, the heart of the communication system. So let's start with the first. We have a input transducer. The input transducer is basically, we can say, a system which basically convert any voice signal or any video signal to an electrical signal. As for example, consider we have a microphone, we are using it, and we are giving a speech, or we can say we are singing a song, anything you can consider. The voice signal, usually what happens, it basically convert to a electrical signal via using microphone. Similarly, we are recording a video using a video camera or using a camcorder. So where what happens, the video signal is basically converted to an electrical signal. So this electrical signal, which is converted now, it actually input to a transmitter. Okay, and the transmitter basically converts this electrical signal into a form which is mainly suitable for transmission through the physical channel or transmission media. Please understand in detail. Consider an example. We have a radio TV broadcast where we having a government or the government of India, which we having a try specify the frequency range for each transmission station. So what happens? The transmitter must translate the information signal to the transmitted into the appropriate frequency range. Otherwise, what happens? This will match to the frequency allocation assigned to. Otherwise, what will happen? It will actually interfere with the other frequency, other signal which having a different frequency. So basically, the transmitter work in this matter in this manner, and then we have a channel. What happened, the channel work like we have, this is basically a physical media we can consider, where we used to send the signal from the transmitter to the receiver. We can say in a wireless transmission the channel is usually the atmosphere, which is a free space. On the other hand, we have a telephone channel as well, where what we do, we usually employ a variety of physical media, or including wire lines or including optical fiber cable. Whatever the media, if we have a channel with any medium, either atmosphere or either a wire, the noise will intervene these signals. So we have to study more in detail in the future about the noises, because this is the major part where the all the communication system is dependent, that how we can minimize these noises so that our the entire communication system improves. So we will study this part later. Then we have at the end receiver, where we have received to recover the message signal what we usually transmitted at the beginning. So we actually in the receiver, the demodulation of a signal may happen. We will see what is demodulation all about, where we usually extract the message signal from the carrier signal what we act initially transmitted at the beginning. So we'll study. So this is receiver all about, and at the end we have a output transducer. This output transducer is basically work the counterpart of the input transducer. It basically convert this electrical signal to their respective. If it is a voice signal, so if this will convert to the voice signal. If it is a video signal, this will convert it to a video signal. So this is all about the major five segment of a communication system. So you can expect, guys, from this topic we have the question may came like what are the explain the elements of communication system, or what are the basic communication component of communication system. So this kind of a question may come in an exam. You can expect, if this question will come, please draw this diagram and explain each block diagram in detail. What I have given you the idea, that will be sufficient to answer this question. So let's see the second topic we have. Okay. Okay, let's start with the concept of modulation here. Going forward, I would like to highlight this picture in here. Here you can see in this picture the basic concept of modulation you can understand. How? You can see there is, here is a three different picture, which is one is a simple paper, other is the with that simple paper you have made a one aeroplane, and the third is this paper with stone. So what is happening, if you want to send a message to your friend who is 1 meter away from you, what you will do, you just simply pass that paper to him, and your friend receive that paper and receive the information which is written over in that paper. In the second case, if the person is 3 to 4 meter away from you, so what you will do, you will just make an aeroplane of that, and you will just throw this aeroplane, and such that that aeroplane paper aeroplane will reach to him and he will reach the message.
But in the third case where the friend is 30 to 40 meter away from you and you can't even the paper aeroplane even can't reach there, so how you will send the information to him? So you can reach, we can do at that moment. You understood that what, why we can't pick a stone and roll this paper to that particular stone and throw this paper, throw this stone towards my friend so that he can able to receive that stone easily, and he can able to retrieve the data from that particular stone by taking the paper out from it. So the similar concept we have in our communication system in case of modulation. Here what we do simply modulate a basic baseband signal with a carrier signal. What is happening, that baseband signal or a message signal having a frequency very less, around 20 hertz to 20 kilohertz. So we modulate this particular baseband signal with a carrier signal which having a gigahertz, sorry, it's having a megahertz of a frequency, and we just merge together this particular baseband signal or message signal with this carrier signal, and just send the information to towards its destination. So in this way what happened, with the help of this we achieve the a longer range of communication as well. We the antenna size is also reduced. We will see how it reduces. We also achieve to avoid mixing of signals, avoiding interference, and as well as there is a multiplexing is possible. So there are the several advantages of modulation. We will see how it is.
So okay, let's start our next topic, that why do we need modulation. As you can see, we have several reasons to have that why the modulation is required. The first and the most important reason is that the reduction in the height of antenna. So we can see, for you guys I have made a clear cut example where I can show you that how the modulation process assist in the reducing the height of antenna. And if the antenna height is very long, so it is very tough to build that communication system in practically. So we have to make the antenna size small, which is practical possible. And even nowadays we have in a mobile, there are the several antennas inbuilt there, and which are in the so narrow size that even we can't see that they in the mobile there are the multiple antennas are put together. So the size of antenna is very important. So we can see that any radio signal, we know that the antenna height must be multiple of lambda by 4, or I can say it should be a lambda by 4, where the lambda considered as a wavelength. Lambda we know is equal to the c by f as per the formula. The c is the velocity of light and f is the frequency of the signal that we are transmitting. So consider we have a baseband signal which having a frequency f equal to 10 kilohertz. So as you can see, the upper the minimum height of antenna, which is lambda by 4, is now will be converted to c by 4f, because 1 by 4 comes from the size of the antenna that we have assumed. So we have put it the value 3 into 10 to the power 8, which is the velocity of light, 4 into 10 kilohertz, which is 10 into 10 to the power 3. So this value comes around 7.5 kilometer. So you can assume practically that to build any communication system with the height of a 7.5 kilometer size of an antenna, is this practically possible? Do you think so? No, it is not possible. So we need a modulation. So how we can do this size of an antenna small? Say consider we are transmitting a carrier signal with this baseband signal, and this carrier signal is having a frequency of 1 megahertz, which is 1 into 10 to the power 6 hertz. So now the antenna of the size, we can see that it is drastically decreases, and now it is a 75 meter only. So we can say that yes, this is practical possible. So this is the reason uh, why do we need modulation, that it's very helpful to reduction in this height of antenna. Okay. Our the next important factor where we can see the importance of modulation is avoid mixing of signals. How it is happening? Say, as for example, we having a baseband sound signals and which are transmitted without any modulation, and all the signal which is transmitted having a same frequency of 20 hertz to 20 kilohertz. So what happens, these signals all gets mixed together and the receiver cannot separate them from each other. So if a baseband sound signal is used to modulate different carrier, we can merge this baseband signal to occupy different slots in the frequency domain, and the modulation which helps in this particular process to mixing, avoid mixing of these signals. And we have other point which is actually the increases the range of communication. Here what happens, the frequency of the baseband signal is very low, as we know. It's around 20 hertz to 20 kilohertz, and these low frequency signal cannot travel a long distance. When they are transmitted, they get heavily attenuated. For example, I have given in the my few minutes ago about we are throwing a paper about 100-meter distance, and the paper is so light that we cannot send this paper by throwing itself. So we put a help of a carrier where which is stone there, and we merge this stone to this particular paper, roll it well, and throw it the paper, throw the stone, so that the paper itself go with the stone, and we can at the receiver side, my friend is able to read the message. So similarly, to increase the range of communication, we require a modulation where we can avoid the attenuation of the baseband signal. So this is the reason that why modulation is required, which is to increase the range of communication. So the last point we have is the with the help of a modulation, the multiplexing is possible. As you know, the name multiplexing is actually the process where we can put two or more signal and transmit together from the same communication channel simultaneously. So this is possible with the help of a modulation. How? The multiplexing, which actually allows the same channels to be used by many signals. So as you can see, in a television we can see that so many different channels are there, and you can see each channel without any other channel interference. So this is only possible with the help of a multiplexing, and this multiplexing is only possible in a baseband signal with the help of a modulation. So this is the one of the most important advantages of modulation, is that we can multiplex the signal together and transmit over the same channel. Okay, so in this video, just I wanted to conclude that we have studied two major part of the introduction of analog communication, that we have studied elements of analog communication, what are the different segments present in the analog communication that we have seen, and apart from that we have seen the concept of modulation and why do we need modulation, and we have seen uh, the different question may ask in this particular in particular section, that the question may come that why do we need modulation and what are the advantages of modulation in the communication system. So you can see this kind of a question in this particular topic, and I hope guys you like my video, and please subscribe my channel to get more video on this particular topic, because I wanted to complete the entire syllabus on this topic. Your comment is very necessary so that I can improve my channel, as well as if you find any technical glitches in the terms of concepts and all, please put the comment over the under the video, so that I can check and rectify the same. And if you have any other demand to make any other videos on the technical topic in ECE and in the instrumentation, please let us know so that I can I can look into it, and if I'm able to do the video for the same, I will do this, I will do for sure. Thank you guys. I will surely
present the part 2 video of it as early as possible. Thank you very much.